Imagine you are driving down the highway,
Yeah.
right? And you are pulling a 20-foot boat.
Oh, man. Stressful enough already.
Yeah, exactly.
Yeah.
So you realize you're running low on fuel and you pull off at the next exit.
Right.
But to use the gas pump, you have to completely unhitch your boat.
Right.
You leave it sitting in some random alleyway. You squeeze your truck into a spot the size of a golf cart, pump your gas, and then you have to back out and somehow re-hitch your boat before you can even leave.
I mean, that sounds like an absolute nightmare.
It's totally maddening. You would probably never buy a truck again if you had to do that.
No, you definitely wouldn't.
Well, the crazy thing is, until very recently, that highly frustrating spatial geometry that was the reality for a lot of electric vehicle drivers.
Yeah, it really was.
And then one of the underlying reasons why, if you scroll through financial or automotive headlines right now, you might actually think the entire EV revolution is just completely sputtering out.
Oh, yeah. The prevailing narrative is everywhere.
Right. Automakers scaling back, inventories just piling up on dealer lots, like a total stall in momentum.
It is a very loud storyline right now, and honestly, it's easy to look at a few isolated data points and just conclude that, well, the transition has simply failed.
Yeah.
But when you look at the underlying mechanics of the market, the physical infrastructure being built, and, the engineering standards being locked in, the reality is far more complex than just some simple doom and gloom headline.
And that is exactly the mission of today's deep dive.
Hmm.
We are looking past all that surface-level sales panic to examine the fundamental, behind-the-scenes shifts happening across the 2026 EV market.
Which is a fascinating space right now.
It really is.
Okay.
Let's unpack this, starting with the hard numbers. When you pull the Cox Automotive Q2 2026 data, the initial shock value is pretty high. I mean, EV volume is down 20.5% year over year.
Right, which is obviously a substantial contraction.
Yeah, 20% is no joke.
But you can't view that number in a vacuum. You really have to trace the trend line back a few quarters to see the actual trajectory.
Right, because a 20.5% drop is actually an upward trend when you look at the recent past.
Exactly.
Because in Q1 of this year, sales were down 27.3%.
Yeah.
And if you go back to Q4 of 2025, they were down an eye-watering 36%.
Yeah.
So the market isn't in a free fall right now. It's decelerating its decline.
Yeah, the bleeding is stabilizing. It's basically finding its floor.
Finding its floor, yeah.
What we are experiencing now is essentially a market hangover.
Hangover.
Yeah, because late 2025 saw this highly artificial spike in EV sales. I mean, it pushed them over 10% of the total market, mostly because consumers were just rushing to buy before all those federal tax incentives and state rebates expired.
Oh, right. Everyone wanted the discount before it vanished.
Exactly. And whenever you pull demand forward artificially like that, you inevitably create a vacuum on the other side.
Makes sense.
So manufacturers misread that temporary spike as permanent demand. They overproduced, and now, well, they are aggressively recalculating their product mixes.
But even amid all that recalculation, Tesla is still holding roughly 50% of the EV market, right? Relying really heavily on the Model Y and Model 3.
They are. But legacy automakers are shifting their weight, too.
Yeah, Toyota and Subaru have actually doubled their EV volume year over year in this exact same environment.
Which is wild.
It is. But the standout detail in the current sales data is that hybrids are kind of quietly stealing the show. Like, overall, new vehicle sales are slumping, but hybrid sales are up 9%.
Well, the macroeconomic factors make that an incredibly logical consumer choice,
It's because of gas prices.
Yeah, gas prices are elevated, so drivers are actively seeking relief at the pump, but they're also seeking familiarity.
Right.
Automakers recognize this, which is why we are seeing legacy gas-only product lines being completely replaced by hybrid-only platforms now.
I always look at hybrids as a nicotine patch for traditional car buyers.
A nicotine patch. I like that.
Yeah, it's a very comfortable stepping stone. You get the immediate financial benefit of fuel efficiency, and you get a little taste of that instant electric torque, but you don't have to fundamentally change your daily habits.
No new routines to learn.
Exactly. But this actually sets up a fascinating paradox. We have this whole narrative of dipping EV sales and consumer hesitation, right?
Right.
Yet, when you look at the 2026 AAA car guide, pure electrics and hybrids absolutely dominated.
They really did. They swept almost every major category.
Yeah.
And it's worth noting that AAA evaluates vehicles on an...
And then the only hybrid to snag a category win was the Honda Civic Hybrid Sport Touring in the small car segment. So help me square this.
Okay.
If electric vehicles are objectively outperforming traditional gas cars in performance, safety, and overall design, Why are buyers balking?
It's a great question.
Why is there such a massive disconnect between an award-winning product and a hesitant consumer base?
Because the consumer is evaluating an entirely different metric that, honestly, automotive engineers often completely underestimate.
Which is?
The fueling experience, the vehicle itself is phenomenal. The hesitancy is entirely wrapped up in the anxiety of how you fuel it.
Ah,
Think about it. When you purchase a combustion vehicle, you never spend a single second worrying about whether a gas station will be available on your route, right?
ever.
You don't worry about whether the pump nozzle will physically fit into your car, or whether the pump's credit card reader will just be broken when you arrive.
Right, just works.
Exactly.
Yeah.
But for early EV adopters, public charging has historically been this fragmented, confusing, and highly unreliable experience.
Which brings us to a shift that is going to fundamentally change that dynamic. We are living through what I like to call the USB-C moment for the automotive world.
That is the perfect analogy.
You remember how for years everyone had that junk drawer stuffed with random phone chargers?
Oh, yeah, a total mess.
You had micro USB, mini USB, Apple's Lightning cable. You'd go to a friend's house and ask for a charger, and it was basically a coin toss whether it would actually fit your phone.
Usually it didn't.
Exactly. And then the tech industry finally gave up the turf war and settled on USB-C. One plug for everything. Well, that exact unification is happening to electric vehicles right now.
And the speed at which it occurred is practically unheard of in the automotive
It
sector.
happens so fast,
We are talking about the standardization of the SAE J3400 plug.
which most people know as NACS.
Right, the North American charging standard.
The domino effect here is just incredible. So late 2022, Tesla officially open sources their proprietary connector. They publish all the engineering specs and basically invite the rest of the industry to use this plug they'd been refining for a decade. Then, in May of 2023, Ford makes a shock announcement that they are adopting it.
And that Ford announcement was the catalyst.
It really was.
Once a major legacy Detroit automaker conceded that Tesla's plug was simply superior, the dam broke.
General Motors followed immediately.
Yes. Then Rivian, Volvo, Mercedes, Hyundai, Kia, Toyota. As of right now, 100% of the major automakers operating in North America are committed to the J3400 standard.
100%.
And 2026 is the inflection point. This is the year we are seeing the widespread launch of native NACS ports built directly into the vehicles right on the assembly line.
So no more bulky adapters.
Exactly, eliminating the adapters entirely.
Let's geek out on the engineering of this plug for a minute, because I think it explains exactly why the industry was so willing to abandon the old system.
Let's do it.
The old non-Tesla standard was called CCS, and it was basically a Frankenstein connector.
It really was.
It took a standard circular AC plug and literally just glued two giant DC power pins to the bottom of it.
Yeah, it was huge, it was heavy, and the cables were notoriously unwieldy.
Just massive cables. But the J3400, by contrast, is incredibly elegant.
The elegance comes from its multiplexing capabilities.
Multiplexing.
Yeah, so the J3400 uses a highly efficient 5-pin layout. The two main pins are labeled DC plus L1 and DC minus L2.
Yeah.
What makes this brilliant is that those two pins do double duty.
I see.
If you plug your car into a standard wall charger in your garage, those pins carry alternating current. But if you pull up to a highway fast charger, those exact same pins carry high voltage direct current.
Wow, on the same pins.
Exactly. The vehicle's onboard computer simply switches a contactor to route the power to the right place. CCS couldn't do that. It required separate physical pins for AC and DC.
Which is why the Tesla design plug is like half the size.
Exactly.
Beyond those two main power pins, you have a ground pin for safety and then two signaling pins, right? The control pilot and the proximity pilot.
Yes. Those signaling pins are the brains of the operation.
How so?
The control pilot handles the digital handshake. It's how the station tells the car, hey, I have this much power available. And the car replies, well, my battery is at this temperature, so I can only accept this much.
That's the control pilot. And the proximity pilot.
That's a physical safety interlock. It sends a low-voltage signal confirming the handle is fully seated.
Oh, safety first.
Right. The moment you press the button on the handle to unplug, the proximity pilot instantly cuts the high-voltage flow before the metal pins even separate.
So no sparks.
Exactly. Completely eliminating the risk of an electrical arc.
And it handles a staggering amount of power. I mean, the J3400 standard supports up to 1,000 volts, and we've seen it push to 900 amps.
It's remarkably robust.
But wait, A universal plug doesn't magically fix a broken screen or a dead transformer at the charging station itself.
No, it certainly doesn't.
I mean, if the charger is dead, who cares if the plug fits perfectly? Does a better connector actually translate to a better fueling experience?
Well, a standardized connector is strictly the foundation. It removes the compatibility headache, but you are absolutely right. It doesn't fix the environmental experience.
Right.
Like I said before, a great handshake at the door doesn't compensate for terrible service at the restaurant.
Oh, I love that analogy.
And that realization is forcing infrastructure companies to completely abandon the old spatial model of just, tucking a single lonely charger in the dark back corner of a strip mall parking lot.
Yeah, it always feels sketchy.
Very.
So we're seeing the rise of the flagship charging hub. A perfect example of this is the new EVgo and General Motors flagship station that just went online in Warren, Michigan, sitting right in the shadow of GM's Global Technical Center.
Yes, the Warren location represents a total paradigm shift.
What's it like?
It's designed with the spatial footprint and convenience of a modern gas station. It features 12 charging stalls. It utilizes overhead canopies to shield drivers from rain and snow.
Finally a roof.
I know, right? And it features high-visibility LED lighting to ensure the space actually feels safe and welcoming at night.
But I think the absolute best feature is that they finally built pull-through access lanes.
Oh, yes.
Going back to that boat analogy from the beginning of the show, having to unhitch a trailer just to refuel is maddening.
Terribly inefficient.
Early EV chargers were retrofitted into standard head-end parking spaces, so pulling a trailer was functionally impossible. The integration of pull-through lanes means the spatial geometry of the EV station has finally caught up to a century of established gas station design.
And they are backing up that physical convenience with serious speed.
How fast are we talking?
Well, EVgo is deploying their V4 superchargers at these flagships. These are capable of pushing up to 500 kilowatts of power.
500 kilowatts.
Yeah, that translates to roughly 200 miles of range in about 15 minutes for vehicles that can accept that charge curve.
That is incredibly fast.
And to push that much power without melting the cables, the cords themselves are actively liquid-cooled.
Wow, liquid-cooled cables.
Right.
They also have a feature called Magic Dock technology at these stations, which is basically a brilliant stopgap.
It really is.
Since there are still older CCS vehicles on the road, the Magic Dock integrates an adapter right into the station's holster. If you have a new car, you just pull out the sleek NACS plug. But if you have an older car, you select that on the app, and the station mechanically locks a bulky CCS adapter onto the plug before you pull it out of the holster. Nobody gets stranded.
What's fascinating here is the sheer scale of the demand driving this build-out.
Oh, I bet.
EVgo's internal data shows consumer demand on their network has surged 700% over the last 3 years.
700%.
Yeah, and to accommodate that, they are targeting over 100 of these sprawling flagship stalls to be online by the end of 2026, primarily focusing on high adoption states like California, Texas, and Florida.
Okay, a 700% increase in demand, beautiful canopies, pull-through lanes. I mean, it sounds great until you do the electrical math.
Uh-oh, the math.
Yeah, if you drop a flagship station with 12 500-kilowatt chargers into a city, you're talking about potentially drawing 6 megawatts of power at peak utilization.
Which is massive.
That is a neighborhood-sized power draw. The local electrical grids in most cities are simply not built to handle that.
No, they aren't.
Trenching through concrete, laying heavy-duty conduit, and waiting for the utility company to upgrade local transformers, I mean, that can take years just to get the permits.
You've hit the nail on the head. The grid constraint is arguably the single biggest bottleneck in the entire infrastructure transition.
Yeah.
You cannot simply plug a 6-megawatt facility into an aging city grid without massive, expensive utility upgrades, which is why some organizations are rethinking the connection to the grid entirely.
And to the Metropolitan Area Planning Council, or MPC, out in Massachusetts.
Right.
They're currently running a pilot program called Community EV Car Share across Framingham, Chelsea, Boston, and Quincy. And the hardware they are utilizing completely sidesteps the grid problem you just outlined.
They are deploying units from a company called Beam Global, specifically their EV ARC systems.
EV ARC, okay.
Yes, these are 100% renewable, fully transportable, off-grid solar EV chargers.
To understand how wild these units are, you just have to picture a standard parking space. The Beam unit is this heavy steel base plate that fits perfectly inside the lines of that space, with a pillar supporting a large solar canopy overhead.
It's very clever design.
And because it sits on top of the pavement, it requires zero construction.
None.
No concrete trenching, no electrical permitting, and absolutely no utility bill because it isn't wired into the city grid at all. You literally drop it into a parking lot with a forklift, and it can be charging cars in a matter of hours instead of months.
And the mechanism for how it delivers that power is crucial.
How does it work?
Well, it's not just passing a weak trickle of live solar energy directly into the car, that heavy steel base plate.
Hmm.
It is actually a massive internal battery buffer.
Oh, the base plate is the battery.
Yeah, exactly. The solar canopy trickles energy into that base plate battery all day long. So when a vehicle plugs in, it draws high-speed power directly from the stored energy in the base plate.
So it works at night.
Right, it allows it to charge reliably even at night or on heavily overcast days. Each unit can generate and store enough energy to deliver up to 265 miles of electric driving per day.
Which makes it a phenomenal tool for social equity.
Absolutely.
The MEPC pilot is taking these off-grid chargers and pairing them with Zipcar to serve communities historically sidelined by the EV transition.
It's a great initiative.
Yeah, I mean, if you live in an apartment building or public housing, you probably don't have a dedicated garage to install your own charger. By dropping these off-grid solar units directly into municipal lots and public housing developments, they bridge that gap immediately.
And the programmatic details make it highly accessible. For eligible low-income and housing authority residents, the annual Zipcar membership is reduced to just $35.
Which is like a 60% discount.
Exactly. And the hourly rental rate is locked in at $11 to $13. That single hourly rate covers the vehicle, the insurance, the maintenance, and the off-grid charging.
And the fleet itself is really solid. They're using Kia Niro EVs, which get about 243 miles of range, and Hyundai Kona Electrics, which get about 258 miles.
Good cars.
Yeah. But I have a hard time squaring this solar model with real-world human behavior.
What do you mean?
Well, even with a battery buffer in the base plate, a solar canopy has a hard limit on how many kilowatt hours it can generate in a single day. If someone rents the Zipcar, drives it 200 miles, and totally drains the battery, the next renter is going to show up to a dead car that needs days to recharge on solar power.
It's a very valid concern regarding the math of energy generation versus consumption, but the operational behavioral data resolves it completely.
Really?
Yeah.
Yeah.
The MAPC analyzed Zipcar's historical usage data for the Boston region, and the median trip length for a car share user is only 25.5 miles.
Oh, wow. That's short.
Yes. On average, users are returning these vehicles with 68% of their battery capacity still remaining.
Ah, I see. So they aren't even coming close to draining the 250-mile range on a typical grocery run or doctor's appointment.
Exactly. Because the vehicles sit idle between these short reservations, the off-grid solar chargers have an abundance of time to replenish the 20 or 30 miles of range that was actually consumed.
Got it.
The buffer easily handles the real-world demand profile.
So what does this all mean? When you zoom out and look at the actual engineering and infrastructure being deployed, the headline that EVs are dead is fundamentally misreading the room.
Without a doubt.
Yes, the market is experiencing a stabilization period after a wildly artificial sales spike. But look at the foundation being poured underneath that market correction. The industry has ended the plug wars and universally adopted the highly elegant J3400 standard.
Thank goodness.
Right. Infrastructure companies are abandoning the dark corners of parking lots to build massive 12-stall, liquid-cooled flagship stations with pull-through lanes, so you don't have to abandon your boat just to charge.
Exactly.
And for the locations where the electrical grid simply can't handle the strain, we are dropping off-grid solar stations equipped with massive battery buffers right into parking lots in a matter of hours. The transition isn't stalling. It is actively solving its biggest bottlenecks.
And I'll leave you with the final thought to mull over, building directly on that off-grid solar technology.
Okay, let's hear it.
For roughly a century, the global automotive fueling model has been entirely dependent on two things: a massive, centralized distribution network and highly specific environmentally hazardous real estate.
This traditional corner gas station.
Right, with its massive underground storage tanks.
Right.
But if high-powered off-grid solar chargers can be dropped into any generic parking space anywhere without utility companies or heavy construction, what happens to that multi-trillion-dollar real estate monopoly? We might not just be watching a shift in the mechanics of what powers our vehicles. We might be watching the total permanent decentralization of automotive fuel itself.
A total decentralization.
Yeah.
That completely reframes the timeline of how we adapt our cities. So the next time you see a headline claiming the EV market has hit a wall, Just remember, you don't look at a landscape covered in scaffolding and heavy machinery and call it abandoned. You're just watching it being built.
Thanks for joining us on this deep dive, and keep questioning what you read. We'll catch you next time.